So this video is to continue the Unit 3 review from Stony Point High School Algebra 1. This video is an example of finding slope or rate of change from a graph. So here's my graph. It says a savings account be modeled by the graph of a linear function shown on the grid. What is the rate of change of the balance with respect to the number of withdrawals? So again, anytime you see the word rate of change or the phrase rate of change, they're asking you for slope, okay? Remember, slope is represented by the letter M, which is found by finding the change in Y over the change in X. On a graph, that is typically found by finding the rise over the run, but you can also use the slope formula y2 minus y1 over x2 minus x1. So again, change of y over change of x is typically used in a table, rise over run is typically used in a graph, and the slope formula is typically used for 2 points. Now the slope formula can be used for a graph and a table as well, which is really nice. So one of the very first things I want to do here is just see if my my graph has a positive slope, a negative slope, or a special case slope of being either 0 or undefined. So a positive slope is something that increases from left to right. Negative slope will decrease or go down when you read from left to right. A 0 slope will go left and right and not go up, a horizontal line. And undefined slope is a vertical line that travels straight up and down. You may have seen this represented by SlopeMan, which has 2 eyes and eyebrows, a nose, and a mouth. So this is SlopeMan. And what I notice in this picture is that this line travels down as you read from left to right. And that looks like the right eye, which shows a negative. So what it tells me is that this line has a negative slope. So if I had a multiple choice question, any positive slope or that of 0 or undefined, I could actually eliminate right off the bat. So now I'm ready to actually find the slope of this graph. One of the first things that you want to do when you're finding slope from a graph is identifying 2 good points. And 2 good points could be a point that is an endpoint like this one, or a point where it falls on grid lines perfectly like this one. So I need to find 2 points for this problem or for any problem. And what I notice is that even though this is an endpoint, it's not really falling on a nice grid line. So I'm not going to use that point, but I am going to use this one because again, it falls on that grid line. And I'm going to use this endpoint because it does fall on a nice grid line point. Okay, so those are my 2 points. And it's hard to see, but this says 1,000. And this is right at 1, 2, 3, 4, and 5. So the point up here is at 1,000, and our other good point is at 5, 0. So now I'm ready to count my rise and my run. But we did say it was a negative, so instead of rise, it's really going to drop, which is going to create that negative value. So I'm going to drop from 1,000 all the way down to the second point, which was at 0. So from a y value of 1,000 to a y value of 0, that drops a negative 1,000 units. And so that would be my rise or my drop, if you wanted to keep that wording going. And then my run from left to right goes from an x value of 1 to an x value of 5, which is a run of 4 units. So my slope, change of y, which is my rise, which is negative 1,000, over my change in x or run, which was a positive 4 units. And then I want to reduce that. So negative 1,000 divided by 4 is negative 250. So that would be my slope by using rise over run. I'm going to do this problem one more time, but this time I'm going to do it using that slope formula, y2 minus y1 over x2 minus x1, to show that you get the exact same answer. So with the slope formula, you want to identify 2 points, which we did. We identified 1,000 and 5, 0. And then I'm going to label those points x1, y1, x2, y2. And then I'm going to rewrite my formula, y2 minus y1 over x2 minus x1. And I'm going to plug in those points. What I like to do is write out the formula without any numbers, which would be the fraction bar and then 2 negatives. And then I'm going to plug in those values. So y2 is 0, y1 is 1,000. And then x2 of 5 and x1 of 1. And now I get to reduce. So 0 minus 1,000 is negative 1,000. And 5 minus 1 is 4. And negative 1,000 divided by 4 is negative 250, which was the same answer I found when we did the drop of 1,000 over the run of 4. Okay, so our slope in this problem is negative 250. I hope this problem helped.